Hi there, and welcome to this first lesson on how to upward continue data using Excel. It's pretty nice. I just found the way of doing this. You don't need fancy programs like MATLAB. If you've got Excel, then you can pretty much upward continue any data. We're dealing with profile data here. I need to look into whether we can do it for map data as well, but pretty sure there should be a function to do that. Okay, so obviously to start off with, we need some data. I've got magnetic data here over a dark, synthetic dark, located at 10 meters below the surface. What you'll also need is this little data analysis. It's found under the data toolbar. If you don't see data analysis there, simply go File, Excel Options, and then Add-ins. From add-ins, you'll see down here Analysis Toolpack, and Excel add-ins. You just simply press Go. But since I've got that, we'll just carry on from there. So once you have data analysis, and obviously some data, you set in ready to go. So moving on, things we need to know when we do upward continuation, we're going to be using Fourier transforms, is first of all how many data points you have. I'll call that N. What's the length of the profile? We'll call that L. What's the frequency of sampling? We can call that Fx. And obviously how high you want to upward continue the data. So let's just call that height, or H. In this case, let's make that 30 meters. Okay, number of data points. Fourier transforms, or FFT, or fast Fourier transforms, they require that you use, especially with this Excel, the next power of 2. So for example, if we have 1,000 data points, the next power of 2 would be 1,024. So how do we get that? Let's just copy that down, keep the sequence going, wait for it, 22, 24. And then you can, I think, use zeros, but for what I found works the best is you just go equals that one, put a $sign there so it doesn't get incremented, plus 0.001. Actually, I lie, you don't want the $sign, and just automatically fill in the rest of the value. So I mean, it's at the end, it's 24 out of 1,000. We're not too worried about those data points, just padding it up to 1,024. Okay, so the total length of the profile, since we start at 0, would equal 1,024 minus 1 times the sampling interval, which is in this case every 1 meter. So if you sampled every 5 meters, you put 5. In this case, we just leave it as 1. Okay, Fx, that's your dominant sampling frequency, would be equals 1 divided by the length. The terrible Excel, hate you. Okay, close. See, I've got all these viruses. So height going up 30 meters. Everything's now ready to apply the Fourier transform. We can simply go data analysis and Fourier analysis. Okay. Input range, well, that's obviously the data that you want to apply the Fourier transform to. Down here, and output range, let's just put it in the next column. The input range. Output range would be in that column. And press OK. And clearly I've messed it up there because we've got 1,025 data points. So we start at 0. Oops. Let's just do that again. Practice makes perfect. Data analysis, Fourier analysis. Okay. 1024, 1000. That's the one thing always with Excel, is you're going to be skimming through things, but it is what you do. Okay, and there we go. We have the Fourier transform of our original data. The next thing we need to do is work out which frequencies to use for each of these data points. Easiest way of doing that is through an if statement. The first frequency is your DC frequency, so that has a value of 0. The next one we simply say equals if this one is less than or equal to 512, half of 1024, that value else it's going to be negative 1024 minus your count, your sample number. And let's see if that works. So it should go up positive values from 0 to 512, 300, 400, there we go, 512, and then 511, 10, 9, 8, 7, 6, 5, all the way down to, back down to -1. The next thing we need to do is work out the actual, so that you can think of as a frequency number. Not sure the exact term of it, but that's what I'd like to think of it. And the actual frequency for these data points is simply equal to absolute value of that one times your frequency number times your dominant frequency. That one we can simply copy down. Nope, we made a mistake there. Dominant frequency I, so it's $, so then it stays fixed on I. There we go. So that one times I. Next you have to apply your, work out your upward continuation operator. That's simple, that's exp exponential of -2 times pi. You put in those brackets so that it gives you pi. You can return as many significant digits as you want. If you leave it blank, it puts in the full value of pi, times your frequency times your upward continuation height, in this case 30 meters. You learn your lesson this time, put the $sign there, so when you copy it down it keeps that value fixed. Okay, and there we go. The next thing you have to do is apply your operator to your Fourier transformed data. In that case it's equals, and notice these are complex numbers, so you have to use improduct, imaginary product. It won't work because I think it saves these numbers, your complex numbers, as text. So if you use improduct, then it sorts that out for you, imaginary product. Simple enough. And then it says number 1, number 2, so that would be your first number, C1. You want to multiply it by your upward continuation operator. Copy this down, just make some space here. There we go. Okay, but then we're still in the frequency domain, which is great, but usually present data in the space domain, so we now do the inverse of this. Again, we go data analysis, Fourier analysis, great. You want to put input range G to G and output J. So G being column G, and we want to output in column J. We want the inverse. And there we go, that's the output, which looks about right. So Now with the output, the problem is, if you see there's this number is cell formatted as text. That's one of the problems with using this, is it outputs these things as text for some reason. You can ignore error, you can convert to number. What I generally do is, just to save, make it your life easy, equals that one times 1. And there we go, we're back to normal numbers. Of course that won't work, because you can't just copy down, you have to be in the next cell, equals that one times 1, enter, happy, can copy that down. Now let's have a look at the results. So now we're back in the space domain. Let's plot up some of these results and see what they look like. So insert, just move that across, insert, scatter, I don't know, choose one of these, that one, click select data, add X values. Obviously we can just say sample numbers, so great, this is now the original data. So let's just call that old, and remember that's over synthetic dark, modeled at 10 meters below the surface. So that would be your nanoteslers, and that would be your distance, especially in this case because you used a sample interval of 1. Let's see what the output looks like. We can add it to the same graph, why not? Add X values, well, your X values would be the same. Just do it the easy way. And your Y values, now this time it would be the new data, and we can call this new, or probably should have called that upward continue data or whatever, and it looks wrong. Let's just see something, select data, edit, there we go, there's our problem. It's a bit worried there for a moment. What you want to do there is get all the data points. There we go. Okay. My virus keeps popping up. I know this machine's going to crash soon because of that. And there we go, that's your upward continuation data. Let's see how this looks now there we go, that's your upward continuate data. Let's prove that this thing works properly. I've got synthetic data for a dark at 30 meters, so it would be a 10 meter dark going up 20 meters. Everything recalculates apart from J and K for some reason. Again, I think it's because it comes out as text. So you'd simply have to go data analysis, Fourier analysis. Okay, it says G, J, inverse, great. There it goes, equals this one times 1, enter. And there we go. Okay, let's see if this makes sense. Let's use this and compare it to, let's actually do this. Bring in new data from text, dark 30 meters, open, delimited, next, space, next, finish. Okay, delete. Let's see how, let's see, we've gone up 20 meters on what was originally 10 meter dark, so it should be equivalent to our 30 meter dark data. Let's just plot that, select data, add I don't know, let's call this 30 meter data. X values would be the same. I lie, and they'll be on this sheet the same, and your Y values would now be on this sheet up there. And remember, these two should now match. Let's go back to the top, and they match reasonably well. So you can just turn off the markers to get a better idea of the match. There we go, and they match. Excellent. So there we go. That's how you upload continue profile data in Excel. It's useful. Bit of a mission. If you've got MATLAB or something, it might be a lot easier. But I think the most important thing to take away, which a lot of people, self included, is what do these values actually mean. So let's recap again. That's your sample number. Let's just insert, okay, sample number. That's your mag, that's your actual readings. That's FFT. Remember, you've got to pad your data out to the nearest power of 2. That's my phone ringing. Okay, let's see if we can get back here. Okay, so I think that's pretty much that. This is simply n, that is nfx, the absolute of nfx. Remember, this one, n goes from 0 up to 512, and then 500 minus 511 minus 510 all the way back down to -1. That's your wave number. I think that's what it's called. This is your upward operator. This is simply up times FFT. That's okay, that's what things were. That's your output, I inverse fast Fourier transform, and then that's inverse fast Fourier transform times 1. And again, there's your output. So good luck with that, and hopefully that's right. If there's anything obvious that I've made wrong, please fill in it. Please leave a comment in YouTube. Thank you, and thanks. Hopefully more lessons coming soon.